Hello, and thank you for joining me for Physics with Atila. Today we'll be tackling this question posed on the Discord. I'll briefly explain the question so that everyone is clued in. Take a scenario where we have a piston moving vertically downwards with a portal on the underside of the piston. It's moving towards another platform with a block placed on top of it. In this scenario, when the piston reaches the block, would the block then exit the portal on the other side with no momentum whatsoever and therefore simply drop onto the ground? Or B, would it take the momentum from the piston and then shoot out of the portal? The first thing we have to do in this kind of situation is to attempt to remove any amount of unnecessary information. So, first of all, we'll attempt to draw the question in more simple terms. We can take the block as simply being on top of a perfectly still floor. We do this to remove any amount of elasticity in the situation. So we are going to assume that everything is completely inelastic, because in the situation where when the piston hits the platform, the amount of energy being transferred to the platform might cause an elastic force to take place, where the block is somewhat pushed upwards due to the movement of the platform, that kind of thing, and given some amount of initial momentum, which would cause it to then shoot out of the platform. So we're going to assume that everything is completely inelastic and energy is only transferred to heat or friction. Okay? So we have the block on a perfectly flat platform, and then we have a moving pillar of sorts with a portal on the underside. The nice thing about this is it allows us to make our first assumption, and that is that the portal functions solely as a window. The portal itself, as far as I understand it, connects two positions in space by only their position, not any amount of extra physics. The two worlds are not in any motion, they are still. However, it has connected point A to point B only by position. Hence, it functions much like a window. So what we can do is, instead of considering a portal, simply consider a hole in this block, which would allow the piston to enter it into a new area. Now, to accommodate this, what we can do is to look at choices A and B. First of all, the fact that the platform is inclined has no impact on the physics of the situation. Whether the platform were simply like that, with a portal on the underside, we would expect either that the block rests on top of the portal, or that it shoots out with some velocity. This would not change in any way whether the block does or does not have momentum. Secondly, it does not matter what orientation the second portal is in. Gravity is a factor. However, gravity does not affect in any way the motion of the block by giving it extra or taking away momentum, because gravity is simply a force that affects everything equally. If something is stationary on the floor, it feels that effect anyway. If something is in the air, it is either accelerated or decelerated, depending on what orientation you're looking at it from. So, looking at this simply, we can easily say that the block, as the pillar falls down, the block simply enters and does not move whatsoever. Now, why is this in some ways tricky to look at? What causes it to become an issue in people's heads? Why do people think that this might ever be the scenario that actually takes place? Well, we attempt to look at it from a different frame of reference. We look at it from the point of reference of being inside the piston or inside this block and seeing the floor moving towards us with the block on top. In this point of reference, the block looks like it is what has the momentum. It is what is moving, and therefore, when it finally clashes with the block, it will then continue with that momentum and move upwards, hence being ejected, moving upwards through the other side of the portal. Now, what we have to understand from this scenario is that changing point of reference does not change the physics of the situation in any way. An observer would see the same physical phenomena whether he was from one point of reference or the other. So what we can do to avoid being tricked by this type of scenario is to place ourselves inside it. Say we are moving along with the piston. We are in that block. In this scenario, if we were to look down briefly, we would see the block approaching us, and at some point we would collide. Now what would happen? In this scenario, the momentum must be ascribed to the correct object. The momentum in this scenario is solely with the block and with us. We have an associated momentum moving downwards. And hence, when these two collide, the block would not suddenly be ejected into the block, but in fact we would be pushed down. We would collapse onto the ground as the two blocks collided. Our momentum would push us down. So indeed, and even in that frame of reference, the block would remain stationary. And hence, to answer this question, it would be scenario A. Thank you for joining me, and I hope you've